guys, welcome to the fifth video of geometry, the concept video here by GMAT math guy. Well, we're going to quickly revise the fifth portion, which is 3D geometry. It basically requires you to know the formulae, two formulae, surface area and the volume formula for 5 different shapes, and then you can solve any 3D geometry problems that you might encounter in GMAT. Okay, so let's get started. The first one is cylinder. Okay, now a cylinder is basically like a can of Coke. Okay, my drawings are actually so good that even Michelangelo was jealous of me, but so please, I'm gonna try to be as modest as I can. Now, this is a cylinder. It's a can of Coke. Okay, if you cut it vertically, then you can imagine like a rectangle being rolled. Okay, being rolled, and that would form a cylinder. So this will help you in understanding the formulae. Two things that you need to know for a cylinder is one, the height, that's the length of it, and second is there are two circles, one on the top and the bottom, right? That the radius of that. If you have the radius of the circles and the height of the cylinder, you can calculate the volume and the area. The volume is given by pi r square, which is the area of the circle, times the height. Okay, that's the formula for volume. The area is that if you pick up the can of Coke, right, then it would be the entire curved area where the label is, and the red label, and then there is the top circle and there's the bottom circle. So you have to calculate the area for all of these. If you imagine this rectangle, then this length here is basically 2 pi r. This is the height. So the surface area of a cylinder is 2 pi r h. That's the curved area, plus 2 pi r square, which is the area of the two circles, one on the top, one on the bottom. And that's it. That's all you need to know for cylinders. Okay, let's try the next shape. The next shape is a sphere. Oh, actually, even before sphere, let's do cones. So a cone is basically a birthday hat. Okay, it's a pyramid with a circular base. Here what you need to calculate everything in a cone is the radius of the circle, and again the height as usual. Okay, the two things, L is the length of this, and you can see there's a Pythagoras theorem being applied here. Well, the formula for volume is 1/3 pi r square h. So it's basically, if you have a cylinder and a cone of same radius and height, the volume of the cone will be 1/3 the volume of the cylinder. Alright, that's the way to remember it. Area would be pi r square for the circle at the bottom, and pi r l, which is the area of this curve, this triangular portion, the pyramidical portion. Pi r square is for the circle at the bottom. Alright, I'm not going to do the derivation, you don't need it. Just remember these two formulae, you'll be fine. Next is sphere. Okay, a sphere is basically a 3D circle. So a ball. All you need is the radius. Volume would be 4/3 pi r cube. And the area, the surface area of the entire ball, is 4 pi r square. Alright, now remember, if I have a big watermelon, let's say, imagine a big watermelon, it's all green outside, right? The surface area of that is 4 pi r square. If I cut it right in half and make it two spheres, okay, so I have, imagine these two spheres, and I ask you, okay, so this highlighted portions are the red from the inside, and the remaining is green. The radius was r. What would be the surface area of these two halves? It would be 4 pi r square plus 2 pi r square. So the total surface area would increase when you cut it into smaller pieces, but the volume would remain the same. The total volume of the two halves would add up still to be 4/3 pi r cube. So that's how surface area behaves. Just a small trick or a tip that you would need. Okay, so that 2 pi r square is because of these two red areas that have been exposed now to the air. Okay, now the last two shapes are very easy. You've got the cuboid, which is basically a room. The room that you're sitting in is in all likeliness is a cuboid, and then there is the cube, which is a 3D square. Okay, the formulae are very similar. Okay, just that in a square, in a cube, all the sides are the same. You have 3 dimensions, and in the cuboid there's length, breadth, and there is the height. Okay, volume, the formulae are identical. It's just the L, B, and H for cuboid gets replaced by S in the case of cube. So volume is length into breadth into height. Surface area is, well, you have to calculate the area of all the 6 faces of the cuboid. So there is 2 times LB plus LH plus BH. Okay, all the 6 faces. So similarly, volume for cube is S cube. Area would be 6A square. Oh, what am I saying? A. I can't use A, it's S right now. Now the third thing and the only other thing that you need to know for cuboid and cube is how to calculate the length of the diagonal. The 3D diagonal, which starts from one corner of the room and ends at the exact opposite vertex. It's a 3-dimensional diagonal. To calculate this, you will need Pythagoras Theorem applied twice. And the formula for this is basically D is equal to, I'm going to write this in the next slide. D is equal to square root of length square plus breadth square plus height square. And for the cube, this formula would become root of 3s square, meaning s times root 3. Now if you remember, for a square the diagonal was 2d square, it was s root 2. For a 3D cube the diagonal is s root 3. Alright, with that we are done with 3D geometry. See you in the next video, in which we will do coordinate geometry. Alright, bye bye then.